My dear students, by some technical problem, above video is stopped in middle only, so I am continuing. See here, what about these two angles? So these two angles are nothing but alternate angles. So if alternate angles are equal, then what can you say? The lines are parallel. So that's why. So the angular in an isosceles triangle, third side is parallel to one of their angular bisectors. Okay, next one. Equally inclined lines. First of all, you have to remember the definition. Equally inclined lines means a pair of lines L1 comma L2 is equal to 0 are said to be equally inclined to any third line L3 is equal to 0. Here equally inclined means inclination is nothing but angle. Okay, so that means the angle between L1 and L3 is equal to angle between L2 and L3. Then we can say L1 and L2 are equally inclined to the line L3 is equal to 0. Okay, so every pair of intersecting lines are equally inclined to their angular bisectors. Okay, first up to here you just remember. Every pair of intersecting lines are equally inclined to their angular bisectors. Yes. Every pair of lines. This is one line. This is one more line. So these two lines are equally inclined to its angular bisector. This is one of the angular bisector. So this angle between this line and this angular bisector is equal to alpha by 2, and the angle between this line and this angular bisector is equal to alpha by 2. So this is consider L1 is equal to 0, this is L2 is equal to 0, this is some L3 is equal to 0. So the angle between L1 is equal to 0 and L3 is equal to 0 is equal to L2 is equal to 0 and L3 is equal to 0. So we can say here every pair of intersecting lines are equally inclined to their angular bisectors and the lines parallel to angular bisectors. And the lines parallel to angular bisectors. For suppose, so these are the two intersecting lines. This is the angular bisector. Okay, this is the angular bisector means these two lines are equally inclined to its angular bisector. Very clear answer. It is theta. It is also theta. Okay, according to previous concept. So if you draw the lines parallel to this angular bisector like this, okay, what about this? This is nothing but a transversal. These three are parallel lines. So these two angles are equal. These two angles also equal. So what can you say? So these two lines, this is the two intersecting lines. These two intersecting lines are also equally inclined to its angular bisector parallel lines. Because of it is angle theta, it is also angle theta. Okay, so that is the concept here. So that means once again every pair of intersecting lines are equally inclined to their angular bisectors and the lines parallel to angular bisectors also. Okay. So next one concept is acute angle bisector, obtuse angle bisector. So already I told you when we have to take so out of these two lines, which one is acute angle bisector, which one is obtuse angular bisector. This is the concept, very important. So if you remember these conditions, we can say directly. So concept you have to remember. This is based on observation. Okay. So acute angle bisector, obtuse angle bisector condition. For suppose they given a1x plus b1y plus c1 is equal to 0, a2x plus b2y plus c2 is equal to 0. Here a1, b1, c1, a2, b2, c2 are the corresponding coefficients of the given lines. So then if the condition a1, a2 plus b1, b2 is positive, so a1, a2 plus b1, b2 is positive, then acute angle bisector, you have to take negative case. Negative case means in this one you have to use minus. So in this, if it is positive, so acute angle bisector is negative. So automatically obtuse angle bisector, just shortly I am written, obtuse angle bisector is nothing but positive case. Positive case means we have to use positive sign. Okay. Next one. If a1, a2 plus b1, b2 is less than 0, then acute angle bisector is positive, obtuse angle bisector is negative. Just remember, very important. Okay, very clear. So a1, a2 plus b1, b2 is greater than 0, positive. then acute angular bisector negative case, obtuse angle bisector positive. A1 A2 plus B1 B2 is negative, then acute angle bisector is positive, obtuse angle bisector is negative. Next one, same way, angle bisector containing the point x1 comma y1. For suppose if you go for this one, okay, so these are the two intersecting lines. This is angular bisector, this is angular bisector, okay. For suppose it is here any point x1 comma y1 is there in this angle, it is acute angle, it is obtuse angle maybe, okay. Let us consider, so let us consider if the point x1 comma y1, okay, x1 comma y1 containing which angular bisector. If you want to find out the point x1 comma y1 containing which angular bisector, that is the important. For suppose x1 comma y1 is here or here, we don't know, so that may be obtuse angular bisector or acute angular bisector, so we have to find out the in that case also. So angular bisector containing x1 comma y1, so condition based on x1 comma y1 only, it condition is there, okay. So for suppose x1 comma y1, if you substitute in first equation, that is denoted with L11. If x1 comma y1 substitute in second equation, that denoted with L22. Take the product of these L1 and L22. If L11 into L22 is greater than 0, so angle bisector containing x1 comma y1 is positive case. That means x1 comma y1 containing positive case means we have to use plus sign. So in that L11 into L22 is greater than 0, L11 into L22 is greater than 0, then positive case equation we have to consider for angular bisector containing x1 comma y1. Next one, same way, if whenever if L11 and L22 containing, that means sorry, here x1 comma y1 angular bisector containing x1 comma y1 in positive case, then in negative case it is not containing, very clear observation, okay. L11 into L22 is negative, then angular bisector containing x1 comma y1 is a negative case, okay. Automatically in positive case, that x1 comma y1 not lying, okay. So these are the two important tables, we just remember. Next one, if two lines L1 is equal to 0, L2 is equal to 0 are parallel to adjacent sides of a square or rhombus, then angle bisectors of two lines L1 is equal to 0, L2 is equal to 0 are parallel to diagonals of the square or rhombus. See, once again, if two lines L1 is equal to 0, L2 is equal to 0 are parallel to adjacent sides of a square or rhombus. Let us consider this is either square or rhombus you take, okay. So if it is a square or rhombus, so all sides are equal. So all sides are equal means uh, if you take, this is nothing but what here, angular bisector, okay. Diagonal is nothing but it's an angular bisector of adjacent sides, very clear. So if you drop, if you take two lines which are parallel to adjacent sides, this is parallel to this one, this is parallel to this one, just remember, okay. So now the angular bisectors of these two lines which are parallel to the adjacent sides of square or rhombus are nothing but parallel to its diagonals. This is parallel to this one and this is parallel to this one, very clear. You have to remember this concept is important. Whenever they given question based on this one, you just if you remember this one, you can get the answer, okay. See once again, if two lines L1 is equal to 0, L2 is equal to 0 are parallel to adjacent sides of a square or rhombus, then angular bisectors of two lines L1 is equal to 0, L2 is equal to 0 are parallel to diagonals of the square or rhombus. If it is the given square, so diagonals are parallel to that means the angular bisectors are parallel to diagonals of the square. If it is rhombus, so angular bisectors are parallel to diagonals of the rhombus. Very clear answer. Next one. image of ax plus by plus c is equal to 0 with respect to the line lx plus my plus n is equal to 0. This is angle bisector. This reference, this is the with respect to the line. So a image of ax plus by plus c is equal to 0 with respect to the line lx plus my plus n is equal to 0 is ax plus by plus c by lx plus my plus n is equal to 2 times of al plus bm by l square plus m square. Here abc are nothing but for which line equation we are going to finding image coefficients. Here lx plus my plus n is nothing but a reference line. Okay, so let us consider this is the line lx plus my plus n is equal to 0. This is the line ax plus by plus c is equal to 0. Now the image of this line is nothing but this one. Now this reference line, whatever may be you taken, lx plus my plus n is equal to 0 is nothing but angle bisector of these two lines. Angle bisector of these two lines. That's why I given in bracket a angle bisector. Very clear observation. Okay, image means, so if you take image means for this one, image is nothing but this one. So image means if you take any point on this line, anywhere you can take any point from this point, perpendicular distance to these two lines are equal. That means if you take here one point, the perpendicular distance from this point to this line equal to this point to this line. So like that, if you take anywhere you can take, then this line is nothing but uh, angle bisector of these two lines. So based on that angle bisector concept, you just you got this answer. You got this answer for this image. For this image, this is the answer. This proof is nothing but if you apply the what I given concept, what I explained concept, angular bisectors concept, you get the answer. Okay, so here concept, that means proof is not important but formula is important. Okay, next one, same way in the above what we discussed. Let us consider this is some smooth surface you take or mirror surface. Okay, and if you go to one incident ray, this is nothing but incident ray, physics concept. Incident ray, if you drop like this, reflected ray like this, refracted ray like this. Okay, for this one, this is the expansion. So these two are nothing but intersecting lines. If these two are intersecting lines, okay, remember, so this is incident ray, this is reflected ray. For this mirror surface, this is angle theta, then this is also angle theta, we know very well. Okay, all of you know in physics. Okay, these two are nothing but a theta theta. If you expand this one, this is also theta, this is also theta. Then what you observe, for this incident ray and for this reflected ray, this is nothing but what is that? This is nothing but angle bisector. If you apply same application, you get the answer. So if may ask, so this is the incident ray with respect to the mirror, any line they may give. Okay, find the reflected ray. If he asks, just to use this concept. Reflected ray formula is nothing but ax plus by plus c by lx plus my plus n is equal 2 times of al plus bm by l square plus m square. Here incident ray equation may be ax plus by plus c is equal to 0. That is mirror, that means mirror is nothing but lx plus my plus n is equal to 0. Okay, so same concept. So based on these concepts, we see some questions. In next video, I'll explain.